Alright, this video is linear programming. It's section 7.6. I need some eyes. Where is it? Where are the eyes? There we go. Alright, so you're going to see that a lot of the things we're doing right now are going to tie into the past two topics, which are systems of equations and systems of inequalities. So linear programming is basically finding the maximum or minimum value for a given function or equation. Alright, so we're given z is equal to 3x plus 2y. We want to find what the maximum value of z is given the following constraints for x and y. Alright, so our first constraint, and this goes back to graphing the inequalities, is that x has to be greater than or equal to 0. So I'm going to use this guy. So that means it has to be to the right of this line, right, the positive values of x. We also see that y has to be greater than or equal to 0. So that means already it has to be in this quadrant. Okay? But we also have these two lines that are constraints. Okay? And again, you know how to do this from the past topic, but I'm just going to go over this again. This line is actually equal to 2y is less than or equal to 4 minus x, which is y is less than or equal to 2 minus 1 half x. So that is starting at 2, and it's got a slope of 1 half, so it's down 1 over 2, down 1 over 2. Alright, there's another constraint right there. Has to be less than that line. So we now have a triangle it has to fall into. But there's one more constraint. The line x minus y is less than or equal to 1 is going to be x is less than or equal to 1 plus y. So x minus 1 is less than or equal to y. So that's a line that starts at negative 1. It's got a slope of 1, so it's going to go right through here. Alright. And that is y is greater than. So that means it's got to be above the line. So we're going to find that the area we're looking for here is this area right in here. Okay? Alright. X is greater than 0, y is greater than 0, and it's less than this line and greater than that line. So the value has to fall somewhere in here for that maximum value. Alright? And what we'll find, this is important, that the maximum value will always fall at one of these vertices. So this is a vertex, this is a flower. This is a vertex, that's a vertex. Alright? This vertex is easy to find, right? It's just where this line intercepts the x-axis, so it's at x is equal to 1, y is equal to 0. You're usually going to have these points on the axes. This one is going to be 0, comma, 2. And then the one that's a little bit trickier to find is right here, which is going back to systems of equations, and it's when this and this intersect. These lines intersect each other. So I'm going to set those equal to each other, and it's going to be 2 minus 1 half x is equal to x minus 1. We're going to get 3 is equal to 3 halves x, correct? And that is going to end up being 6 divided by 3x, so x equals 2. Plug that back in, 2 minus 1, so y is equal to 1. So this point right here is 2 comma 1. So we know that this maximum value has to fall at one of these 3 points. That's just a rule. Okay? And all we're going to do then is we're going to literally just plug them in. So z is equal to 3 times, I'm going to do this point first, 0 plus 2 times y is 2. That's equal to 4. Alright? Then if we have z equal to, I'm going to use this point right here. It's going to be 3 times 1 plus 2 times 0. Define z is equal to 3. So far this is the maximum. Then we have one more point test, 2 comma 1. Z is equal to 3 times 2 plus 2 times 1, and z is equal to 6 plus 2, which is 8. Therefore, the maximum value is 8. Z is equal to 8, and it comes when we use the point 2 comma 1. Alright? That's just the process. You just go through that. You're basically doing a system, you're graphing the system of inequalities. Alright, the linear inequalities, just like we did last section. And then you're testing the vertices, because this maximum value will fall out of vertice. I could have also said find the minimum, and the minimum is equal to, oh, actually, we also consider this as a vertice, right? 0 comma 0, which is going to be our minimum, because that would just be z is equal to 0. Our maximum is equal to 8. Let's do another example. Alright, find the maximal and minimal value of z is equal to 3x plus 4y subject to the following constraints. So this time we just have 3 lines, alright? First line is going to be y is less than or equal to 7 minus 1 half x. 1, 2, 3, 4, 5, 6, 7. Down 1 over 2, down 1 over 2. Alright, didn't get that line right here. That was not good. It's better. So there's one line, and it is y is less than, so we know that it has to be below here. So we're going to get a little bit of a, it's got to be in somewhere in this area. Our second one is y is less than or equal to 3x. So that is just, starts here, and the slope of positive 3, up 3 over 1, up 3 over 1. Looks like it intersects right there. Get that line out. And we know that that is less than, so it has to be somewhere over here. Alright, get that in blue. So we're narrowing down the region that it has to fall into right here, right? So far it's somewhere in this area. But we have a third one, and that is just x minus 2 is less than or equal to y. So that starts at negative 2. And its slope of positive 1. And we're going to see it's up 1 over 1, up 1 over 1, up 1 over 1. Actually crosses right there. Okay. So, we can already see quickly how, what our values are, our 3 vertices are. We have 1, 2, 3. And remember, the maximum and minimums have to fall at one of these values every time. Alright? So first I got to go through and solve and figure out what these values are. And since I graphed it so well, I can actually just look. And this is going to be 2, 1, 2, comma, 1, 2, 3, 4, 5, 6. This one is 1, 2, 3, 4, 5, 6, comma, 1, 2, 3, 4. And our last vertice is negative 2, comma, 1, 2, 3. Check to see if that one works. question, we go ahead and set these equations equal to each other just to check, because that one's not right on a point. So that's going to be x minus 2 is equal to, which is this line, right, is equal to 3x. So we're going to find that negative 2 is equal to 2x, x is equal to negative 1, like I thought. Then we plug that back in, and it's negative 3, right? Y equals negative 3. So those are our three vertices. The maximums and minimums will fall at one of those vertices. Now it's just a matter of testing. Alright, z equals z equals 3 times 2, I'm going to do that point first, plus 4 times 6. Z is equal to 6 plus 24, which is 30. Our second point, z is equal to 3 times 6 plus 4 times 4. And we find z is equal to 18 plus 16, which is 34. And our last point is negative 1, comma negative 3, so that's going to be 3 times negative 1 plus 4 times negative 3. Z is equal to negative 3 minus 12, which is negative 15. So, this is our minimum value, this is our maximum value. So our minimum falls right here, and our maximum falls right here. Okay? So, maximum is equal to 34. Minimum is negative 15. That's the process. It's pretty straightforward. You're just finding the region. So we found that the region had to be in here. And then you find the vertices, and you test out the points. That's all we're doing. We're going to do some real-world application with this stuff because it's really applicable to real life. But I want you to understand the basis first. We're going to do that stuff in class. So here's the question. Good luck.